Today we're diving into a paper that explores a novel approach to fine-tuning large language models for reasoning tasks. The paper, Training Chain of Thought via Latent Variable Inference, proposes a method called TRICE, which leverages latent variables to represent reasoning steps. Let's start with the core problem this paper addresses. What are the limitations of traditional approaches to fine-tuning LLMs for reasoning?
Traditional methods often rely on supervised fine-tuning, which requires a large amount of labeled data, including not just the correct answers, but also detailed rationales that lead to those answers. This data is expensive and time-consuming to collect. Furthermore, these methods can struggle to generalize to unseen examples, especially when the reasoning process is complex.
So, TRICE aims to address these limitations by introducing a new approach. Can you explain the key idea behind TRICE? TRICE frames the chain of thought prompting process as a probabilistic, latent variable model. The LLM defines a joint probability distribution over questions, rationales, and answers. The goal is to maximize the marginal log likelihood of generating a correct answer, averaging over all possible rationales. That's an interesting perspective. How does TRICE handle the challenge of averaging over a vast set of potential rationales?
TRICE employs a Markov-chain Monte Carlo, MCMC, expectation-maximization, EM, algorithm to approximate the marginal distribution. It maintains a memory of rationales for each question-answer pair and iteratively updates these rationales using an independent sampler.
Can you elaborate on the independent sampler used in TRICE?
The independent sampler proposes new rationales from the current model and accepts them based on their likelihood of generating the correct answer. This process effectively samples from the posterior distribution over rationales conditioned on the correct answer.
So, TRICE essentially learns to generate better rationales by iteratively sampling and updating them. How does this approach compare to existing methods like STAR?
STAR, a similar approach, uses greedy decoding to generate rationales, which can limit the diversity of the training data. TRICE, on the other hand, uses a probabilistic approach that allows for a wider range of rationales to be considered.
That's an important distinction. What are the key advantages of TRICE's probabilistic approach?
TRICE is less likely to ignore difficult examples, which can lead to more stable convergence and improved performance. It can also learn from incorrect rationales, providing a more robust learning process.
You mentioned that TRICE incorporates a control variate scheme. What is the purpose of this scheme?
The control variate scheme helps to reduce the variance of the gradient estimates, leading to faster convergence and potentially better performance. It achieves this by subtracting a scaled control variate from the gradient, whose expected value is 0.
Can you explain how the control variate is computed and applied?
The control variate is computed based on the leave one out estimates of the average probability of accepting a new rationale. It is then scaled and subtracted from the gradient, effectively adjusting the gradient estimate to account for the model's accuracy.
This sounds like a sophisticated technique. How does TRICE's performance compare to other methods?
TRICE outperforms several baselines, including direct prompt tuning, STAR, and rejection sampling, on both the GSM-8K and Big Bench hard datasets. It even surpasses models trained on human-generated rationales, suggesting that it can effectively learn to generate high-quality rationales from scratch.
That's impressive. What are the potential limitations of TRICE?
TRICE is a gradient-based method, which may not be suitable for all LLMs, especially proprietary models that do not provide access to gradients. Furthermore, its performance may vary depending on the size and architecture of the LLM.
Are there any other limitations or potential areas for improvement?
While TRICE focuses on generating correct answers, it does not explicitly evaluate the quality of the reasoning process itself. Future work could explore methods for evaluating the interpretability and soundness of the generated rationales.
To wrap up, can you summarize the key contributions of this paper?
The paper introduces TRICE, a novel method for fine-tuning LLMs for reasoning tasks using latent variables to represent reasoning steps. Trice leverages a probabilistic approach, incorporating MCMC and a control variate scheme to achieve significant performance improvements over existing methods.
This was a fascinating discussion on the technical aspects of Trice. Thank you for sharing your insights.